Hello, everyone, and welcome to the third webinar of WaPOR webinar series 2021. My colleague Anna Marie will be hosting today's webinar. Welcome, Anna Marie, and floor is yours.
Thank you, Abdurrahim. Welcome. Good morning, good afternoon, good evening, everyone. Today's webinar is the third one of a webinar series of 2021 and will focus on new WaPOR applications for agriculture. Let me share my screen. Yes. So my name is Annemarie Klaassen. I work at eLeaf as an expert in remote sensing for agriculture and water management with a strong focus on evapotranspiration. It's an honor to host this webinar. I'm looking forward on today's presentations on different applications to improve water productivity. But first, a bit on the WaPOR project that is responsible for this webinar series. WaPOR stands for Water Productivity Improvement in Practice. And it aims basically to improve the understanding of water productivity, how you can improve it, and how to use the WaPOR database for it. And it includes a lot of capacity building activities around water productivity and the WaPOR database. So the concepts, how you can apply it, we try to raise awareness and how you can use WaPOR for field-based applications, and how you can analyze and interpret water productivity and provide recommendations on how to improve it. There is a lot going on, which is all shared online. For example, we had some masterclasses. There's this webinar series. It was also one last year. There are quite some videos. There's a YouTube channel. And next year there will be a MOOC. If you want to access any of these materials, please visit the website, which is at waterpip.unig.org. As already said, it is the third webinar of this year. On the website, you can find the recordings of all the different webinars, also the ones of last year. Please note that there will be another webinar next week at the Cairo Water Week. So today's webinar is about the WaPOR applications for agriculture. And let me go to the agenda. So we will start with the presentation of Abebe Chukala about the WaPOR-based performance assessment in the cloud. Then Abdurrahim Safi will present the diagnostic framework to basically create information from the remote sensing data presented at WaPOR. Then Hemant Servia will present an operational framework to predict field level biomass. And at the end, there will be a Q&A. There are some guidelines for the webinar. First of all, we would like you to engage with the presenters and other participants through the chat box. What you could do, and what we would appreciate, is that you introduce yourself with your name, your country, your scientific interest, or your organization. If you would like to ask questions, which we encourage, please put them in the chat box, and we will go through these in the Q&A session. And as I already told you, all the recordings, presentations, and additional resources will be available on the YouTube channel and on the WaPOR website. So let's start and have fun. So the first presenter will be Abebe. Let me quickly try to get his presentation. Abebe, could you share your screen already? Then I will do the introduction. So Abebe has a PhD from the University of Twente in green, blue, and grey water footprint reduction and associated costs in irrigated crop production. After that, he joined Wageningen University as a postdoc, and currently he is working at ITE Delft as a lecturer and researcher in remote sensing, water productivity, and irrigation engineering. And today he will tell us more about how you can use WaPOR for performance assessment in the cloud. Please go ahead, Abebe.
Thank you, Anne-Marie. Yeah, quite impressive to hear also the trajectory I have been through. So indeed, this is a brief overview of the performance assessment. And well, I have only few minutes, and of course, I will not go in depth on all technicals, but at least I will share some of the resources and things we did. So, of course, before implementing a performance assessment, it's always good to know why we do so. And there are a number of resources to check, but at least there are some main concepts that we want to understand and also tackle while doing the performance assessment. So we want to check if we are doing things right, which is related to operational performance, and also to check our assessment to assess or also strategies. And of course, doing performance assessment is not only limited only to calculate performance indicators. It goes from defining the purpose why we want to do that up to I mean through then implementing that, and also even revisiting if, let's say, action is required. So now I will zoom in only into the indicator parts, and then of course most of the indicators which are related to water balance can be also especially the vertical fluxes captured by remote sensing, and then the vapor WP protocol is related to that. And then this protocol, it gets data from WaPOR, and then do some of those performance and assessment indicators, which are named like uniformity, equity, beneficial fraction, adequacy, land and water productivity. So of course, the application is, as we already defined it, maybe from the beginning, is it's for, let's say, to check the performance of the operation and the resource use efficiency. And this tool, in fact, has been there in GitHub, and of course, that depend on installing a different dependencies for Python in your machine, in your computer. But now with the cloud, we want to, let's say, reduce those hassles when you are installing dependencies package and so on. So so the same, the GitHub, what the resource we have in the GitHub will be still can be run. So it's the same step, about 5 modules, from downloading up to doing the performance and also identifying bright and hot spots. But then now we have it also other versions. So with the same GitHub, we share also the WaPOR Colab version, where you could run it from your drive. So what you need is just only to have a Google account, and then to upload this folder with the name WAPORWP and your drive, and then just to execute. So in your, let's say, in the virtual machine. That is, of course, it's a collaboratory of the Google resource, which is where you could write your own script and so on. But within this also there is, in this GitHub, you will see README for Colab version. So this README tells you step by step how you could upload and also execute those 5 modules to download up to calculating performance assessment. And of course, no, there are still scope and limitation when we are applying this WaPOR WP protocol. It is just tailored to biophysical productivity, that is water productivity defined in terms of or with respect to consumptive water use, and land productivity with biomass with assumed harvest index, as we couldn't have, let's say, spatial, temporal, varied value of harvest index for the same crop. And then the protocol developed for agriculture with a single crop and the same cropping season, at least for one season. And then if one wants to use different starting and end season, then multiple running is required. So then implementing the protocol beyond field scheme level, such as river or country level, then require to understand all those assumptions, because there you cannot find the same planting dates, and also the agroclimatic is different. It means simply we cannot compare the values, because of there are productivity difference which are not manageable by farmers, which includes climate. And also WaPOR data itself, it has its own limitation and so on. Of course, we refer you to check some of one of at least our recent publication in HES in the discussion. So it of course it guides you also how we could do those kind of analysis, and also a clear definition of what are those performance assessments, and also limitation of some of those data. And this is in short my presentation, and maybe I will get back with the question and answer session.
Thank you, Abebe. Perfectly clear. Looking forward to all the questions from the public. So, Safi, please join the chat box now and the screen. Abdurrahim Safi has a master from IT Delft as well. He specialized in land and water development for food security. In the past, he has been engaged in agricultural water management, really in practice with the World Bank funded projects, international NGOs, and currently we're very happy with that. He joined eLeaf as a geoanalyst. Please go ahead.
Thank you, Anna-Marie. In today's presentation, I will introduce a framework that enables practitioners to use remote sensing data, mainly WaPOR, for analyzing spatial temporal variations in irrigated agriculture, diagnose reasons behind these variations, set realistic target, quantify scope of improvement, and finally recommend actions for improvement. I will little bit talk about the rationale for the study and framework. As you know that people are a lot of people are facing hunger in these days, and billions of people are facing water scarcity. So for this reason, it's really important to improve water productivity. And in future, I have a little problem with the screen. Yeah, thanks. Um, in future, the frequent droughts, greater variability in agriculture water supply, increased water demand, growing population, change in eating habits, that will make the situation worse. That's why it's really important to improve water productivity. And remote sensing has been proved that it has accurate, rapid, and cost-effective water productivity analysis capabilities. And a lot of data is available there. But the only important thing is now to translate the data into actionable information. And therefore, we have developed this framework. The first part of the framework is to calculate water productivity and yield figures for each crop field. The second is to identify bright and hot spots. Bright spots means the crop fields that are producing more crop production for less water consumption, and the hot spots are vice versa. And the third step is to identify certain water productivity factors, particularly those who can be identified with the remote sensing data. And finally, to do analysis, uh, uh, factor analysis. Hopefully, sorry. The first step is to calculate water productivity and yield. We did calculate yield and water productivity, and you can see that three crops are selected for this purpose: wheat, potatoes, and grapes. And then we compare these estimated water productivity and yield with the reported, and you can see that will fits into the reported water productivity and yield figures. Um, and there is a little bit difference with the yield estimation of the grapes. We consider here only table grapes, but the reported one is the average of the wine in table grapes, which is um, less than the estimated one. Uh, the second step is to identify bright and hot spot. You can see here in the graph that farmers who are having less water productivity and at the same time less yield, they are poor performance, and they are identified as hot spot, and farmers with the higher water productivity and higher yield or bright spots. Also, you can see on the map who is lying where on the spatial scale. And the third one is to define indicators for water productivity. So this is the list of the water productivity factors, and then indicator for each factor. I will be discussing in the next slides about each indicator and factor. And we applied this framework to Baker Valley in the Lebanon. Um, The first one was water stress on the list. In this graph, you can see that the green line is showing yield production from the sowing to the harvest time, and the change is shown in the graph. And the blue one is showing how the moisture index is changing from time to time, from start of the season to the end of the season. And combining these two graphs, we have a stress sensitivity index, which is actually showing how biomass production is sensitive to the water stress. And this is for the wheat crop. We compared our analysis, our this stress sensitivity index with the literature, and it really fits the previous findings that in initial stages and late stages, the stress sensitivity index is lower, and then in the developing and mid stage, it is higher. The other one was irrigation heterogeneity. In this graph, you can see what productivity, yield, and CVET, which is actually showing irrigation heterogeneity. The larger the circle in red is showing negative correlation, and then you can see here that there is a larger negative correlation between the yield and irrigation heterogeneity, which means that wheat is really affected by irrigation heterogeneity in the Bekaa Valley. Also for the potato, there is a negative correlation, but the correlation for the grapes is negative, but really smaller and not really significant. And that's due to the reason that the potatoes and wheat are irrigated with the sprinkler irrigation, and the grapes are mostly with the drip irrigation. That's why the irrigation heterogeneity is not affecting that very much. And secondly, in the Bekaa Valley has a windy nature. That's why irrigation efficiency and uniformity is not very well there. Other was salinity stress. For the salinity stress, we calculated two indices. One is normalized difference salinity index, and another is near SWIR index. And you can see there is no correlation between the salinity indices with water productivity and yield. For the wheat and for the potato as well. And that's also previous studies has shown that in the Beca Valley, the salinity is not really a threat to water productivity or yield at current times. The other one is a nitrogen stress. Um, Nitrogen content of the crop field was uh, um, predicted in the leaves with the Sentinel data, and you can see that the bright spot has higher nitrogen content with as compared to the hard spots. This means that the nitrogen has played a role in the biomass production there, and that's also the previous finding of the literature. The other was crop rotation. Um, you can see here that the wheat crop rotated with other crops has a higher yield. At the same time, they have a higher water productivity as compared to the mono wheat cropping. We did a t-test analysis to see the significance of the difference, and water productivity is significantly different, but the yield is not significantly different for this case in the bakery. We also look at the soil type. USDA soil classification was used in data from the soil grids were used in this indicator, and uh, most of the crops the crops were lying on the two kinds of the soil, zero alps and zerules, and the results are there that wheat yield and water productivity is water productivity of the yield is wheat is significantly affected, but yield is not. Potato yield and water productivity both are significantly influenced, and grape are affected, but not to the significant level. And that's because of the reason that the zero soils or clay loam soil, which has higher water holding capacity as compared to the zero which has lower water holding capacity. And um, uh, as we know that the wheat is more stress tolerant, that's why it is less affected with the soil type as compared to wheat. The other step is to set improvement target. For this purpose, we did scoring of the crop field with the yield water productivity score. And here you can see that the crop fields are scored from 0 to 10. And also you can see on the map who is performing well. Actually, the scoring is based on the higher yield and lower water consumption at the same time. Scope of improvement is also quantified if we are in a certain situation, and if we want to achieve certain yield score, what will be the improvement. And for this analysis, a total amount of 6.26 million cubic meter of E2 can be reduced if we achieve a score of 9 to 10 for the wheat, potatoes, and grapes only. Also, the increase in water productivity is predicted. You can see that we can have in each one wheat, potatoes, and grapes up to 24 and 35% of the increase in water productivity. That was it. I will stop sharing, and thank you.
Thank you, Safi. Very interesting. So let's move to our final presentation from Hammond. Hammond has worked for more than 8 years in water supply and sewerage projects in India, and he recently graduated with distinction from IHE Delft in using remote sensing for agricultural sustainability. He recently started as a head of remote sensing for the US-based WaterTech's startup Water Plan, and he also works as a short-term consultant with IMI. Well, please, Hammond, join the screen and start presenting. You're welcome.
Thank you so much, Anne-Marie. I would just give me a moment. Yes, a warm welcome to all. I'm Hemant Sarvia, a remote sensing enthusiast and an alumni of IHE Delft Institute for Water Education, Netherlands. Today, I'm presenting our research on developing an operational biomass, framework to predict field level crop biomass using remote sensing and data-driven models. The interesting image that you see in front of you is the graphical abstract of the research. At the heart of this study is the development of a framework that takes inputs from the two satellites, the optical Sentinel-2 and the radar Sentinel-1. In addition to these two satellites datasets, the other two important datasets are the evapotranspiration dataset and the NPP, that is a net primary production dataset from the FAO's WaPOR database. These datasets are then processed and extracted at field level using the field boundaries. This field level information is then analyzed in a statistical framework to predict future biomass estimates at field level that further helps in financial planning and taking other policy decisions. In front of us are the different sections of the research. That is the why, what, where, and how of the research, basically. So keeping in view the limitations of the time, we will walk through a few selected sections only. However, to be aligned with the context of the research, the study area was the large-scale commercial sugarcane farms located in the southwestern region of the Awash River Basin, Ethiopia, called Wanji Shua Sugarcane Estate. So the first section is the methodology. This image depicts the workflow adopted to develop crop yield prediction models per field using remote sensing data. For this research, the primary input, as already discussed, was the remote sensing data obtained from multi-source satellites. For radar satellite data, high-resolution Sentinel-1 was utilized to obtain time series of polarization bands for the study period that extended from January 2016 to October 2020. For radar satellite data, high-resolution Sentinel-2 was utilized for the same period. In addition to the multispectral bands and polarized bands of Sentinel-2 and Sentinel-1, respectively, several vegetation indices were also used as input variables that included normalized difference vegetation index called NDVI, enhanced vegetation index called EVI, red H chlorophyll index called CI, and radar vegetation index called RVI. To take into account the water stresses experienced by the crop during its growth cycle, a third category of model input variable, ETA, was used in this research. That was obtained from the WaPOR dataset. Finally, the last but the most important dataset that was used for this study was the WaPOR-derived NPP dataset that was used as an proxy or as alternative variable to yield and is thus simulated and predicted by the models. Consequently, all the datasets were resampled on a decadal scale, that is on a 10-day scale, with subsequent fillings of the temporal gaps. Therefore, in the next step, the field boundaries in the study region were digitized based on the pathways between the fields and based on the heterogeneity in the greenness of the fields arising due to changes in the cropping practices. Once the digitization process was complete, the values of different variables were extracted per field. In addition to these variables, one very important variable that was the field level phenological information, the seasonal patterns, was derived using a semi-automated approach based on relating time series NDVI data of different fields, followed by the visual inspection of a few selected ones. Therefore, all the variables, including the independent and the dependent variables for the model development, were now available for every field to be used to develop the sugarcane biomass prediction models iteratively. Why I say iteratively? Because in the subsequent step, the training and validation datasets were generated from all these variables that we just discussed to train and develop the crop yield prediction models. Importantly, as per the developed framework, this is iteratively done for all the fields corresponding to different tested lead times. Therefore, in a nutshell, a prediction model was developed for every field corresponding to every lead time. And here we finish the methodology. Coming to the next section, that is the result section. Now this presents the fields with their completed number of cropping seasons during the study period. Importantly, the general phenology of the region was important and thus considered while reducing field level phenology. As observed, most of the fields in the region experience 3 to 4 cropping seasons, highlighted with yellow and green colors. However, and notably, the red fields with 5 cropping patterns were mainly located in the northeastern part of the study area, which we will discuss why later. So, notably, the red fields again were mainly located, as I said. The performance, so in whole of this development of models, 5 regression algorithms were tested. So those were, 2 of them were the linear models and 3 of them were the machine learning models. And the 2 that were the linear models were the MLR, that is the multivariate linear regression, and the second one was SMLR, that is a stepwise multivariate linear regression. And the 3 tested machine learning models were BRT, that is the boosted regression trees, SVR, that is the support vector regression, and RFRs, that is the random forest regression. And when we present the results, the performance of all the 5 regression techniques were compared based on the values of their coefficient of correlation, and the results are presented in the graph in front of you. The linear regression models outperformed all the tested machine learning models, as can be seen with the values of R square, that is the coefficient of correlation. Multivariate linear regression, that is MLR, exhibited the highest prediction accuracies, while support vector regression, one of the machine learning regressions based models, performed the worst. Different test cases involving different combinations of control variables were also tested to reach to the most optimal set of predictors or the input variables for the models. As expected also, if it can be observed, the prediction accuracy is reduced as the lead time increased for most of the tested algorithms. This may be due to the reason that further we predict in future, there are high possibilities of conditions getting changed in between, and hence higher uncertainties and less accurate predictions. Further, the interfield differences in prediction errors were analyzed, and it was observed that even for the most accurate crop yield predictions, although the mean prediction error for all the fields combined was very low, the distribution of error within different fields was quite diverse. This may give rise to a situation where some of the fields might have very accurate yield estimates, while the others having erroneous predictions. As obtained, the mean absolute percentage error for all the fields was only 10.8%, but some of the fields lying in the northeast, again, as we discussed earlier, were having high prediction errors lying in the range of 20% to 70%. And these were the fields that were later found to be associated with change in cropping patterns, and thus more cropping seasons and lower seasonal average biomass of the crops. Although all these observations for these northeastern fields suggest of recent changes in the agriculture practice in the region, but again, it needs ground truthing and further exploration. Finally, the conclusions of the study. With the results obtained from this research and their interpretations thereof, the following may be concluded. Using an automated framework, the empirical model developed per field based on MLR approach yields the most accurate sugarcane biomass predictions for the study area. In general, the linear regression models clearly outperform the intuitive or the most expected machine learning regression techniques. Regarding reliable crop yield estimates, high prediction accuracies can be achieved to predict crop biomass with accuracies as high as 95% to 89% for lead times of 50 days to 4 months. Thirdly, it is concluded that the cumulated optical vegetation indices have higher prediction powers in influencing the forecasted biomass, with EVI, that is the enhanced vegetation index, being the most influential variable. It was followed by the radar-derived VH, that is vertical horizontal polarized band values, and then the crop water stress indicator variable called ETA. And final conclusion, it was concluded that for a lead time of 12 decadals, that is a 4-month period, reliable yield estimates could be obtained with an average accuracy of 89%. overall, this study contributes in conceptualizing and developing an operational framework to iteratively develop empirical yield prediction models per field instead of usually being done at a regional or a national level. This can be of very high practical significance to the farmers as well as to the policymakers. The prospective contribution of the study is, if the present research is translated into practical application, it can significantly contribute in achieving two main SDGs. SDG 2, that aims to eradicate hunger, attain food security and malnutrition, and advancing sustainable agriculture. So if reliable crop yield estimates can help nations in deciding their strategies to deal with the menace of hunger and malnutrition by maintaining national food reserves, and therefore the nations can be better prepared before these events actually happen. So this can help nations in achieving food security and thus contributing to target 2.1 of SDG 2. From the farmer's perspective, the information from these models, if used, can be used to take informed farm management decisions. It can not only help them in identifying potential gaps in agriculture practices, but it can also support them in adapting to sustainable agriculture. Therefore, this study can contribute in increased agrarian economic output, especially for the small scale food producers, and thereby contributing in achieving target 2.3 of SDG 2. And then the other SDG is SDG 12, whose target is 12.3, is to reduce per capita food wastage by 50%. Since the estimates can buy time for the governments in ensuring supply chains between the food surplus and food shortage zones, such interventions will not only avoid wastage of food at its place of production, but will also avoid its loss during transportation activities. This research was done by me, Dr. Sajid Pareed, Dr. Claire Miklowski, Dr. Charlotte De Fletcher, and Dr. Pulad Karimi from IHE Delft, and it was presented by me today. Thank you so much. Over to you, Safi.
Thank you, Hemant. Excellent presentation. Also nice to see how you put it in a wider context of the SDGs. Safi, I think we can go to the Q&A.
Yeah. Also, oops, yeah. The first question is the first question is from about the data used, non-WaPOR data use. For my research, I used mainly WaPOR data, but I also used data from Sentinel and Lancet for the salinity index and moisture index calculation. And also I used data from soil grids for soil type analysis. Yeah. That was the first question. And I think the second question for Simon. Yeah. Yes, as we did the t-test analysis, so what productivity is more affected influenced by crop rotation than the yield. So that we cannot say with just one analysis or one study. We have to do further study for this, but in this study, it shows that the water productivity is more affected. So yeah.
Then the next question has already been addressed in the chat box, but maybe good to mention it again. All the data that was used here in all the presentations called the WaPOR dataset are available online in the WaPOR database. Just Google FAO WaPOR and you'll find the database and be able to download it. Furthermore, there are quite some tools to use this data. IHE Delft has some tools in GitHub that help you to download the data. You can use it in Google Engine. I don't know if you need a specific account for that, but it is available. So yeah, please drop us a note if you want some help with that. Let's go to the next questions.
Yeah, there is another
Another one for you.
question from Maria. I think this question is also for me.
Yeah.
Yes, for the nitrogen index, I used Sentinel data, and Sentinel band with wavelength 783 and 705 are used, and that index is called the simple ratio index. Um, that's basically used to detect nitrogen content in the crop leaves, but that value is an index, and there should be more study to understand how the index is related to the actual nitrogen application in amount. I mean, in kgs or in tons. To translate that index into actual amount. There should be more study, I would say, but at least from our analysis, we have identified that nitrogen is playing a role in the yield production, and yield is affected with the nitrogen application.
Yeah, so it's a
With
very good
Yeah,
index.
with the exact to translate index into the amount of nitrogen. In this case, we also can do something not to over apply nitrogen. It's also really important to not only to apply less, but also the more is also a problem for environment and also for the crops as well. So that's why I would recommend more studies on how to translate these indices to the actual amount in kilograms or tons. Yeah, I hope that's the answer.
Thank you. The next question is for Hammond, and it's about 89% accuracy, whether that refers to the crop yields or just biomass production.
Thank you, Sander, for the question. The 89% accuracy was achieved for a crop biomass prediction, and this was for a lead time of 4 months, that is 12 decadals. But as we know, like there are obviously this is not something very easy, but biomass is a direct indicator of yield uh, in for a specific crop in a given region. So this can be translated to yield based on some experimental data, based on some past data. So this can be translated into yield, but for the purpose of this study, this was done based on the crop biomass prediction.
The next question is related to the limitation related to crop variation with WaPOR. How are you planning to overcoming this challenge? Mm,
I don't know if this
yeah,
question is for me or for Hemant.
well, you
Shall
can
I
answer
take this?
both.
Okay. Okay,
Well,
I
do
will.
both. I think that would be nice to hear both views.
Yeah, yeah. In my case, really, the crop variations that's really important. Each crop is responding in different way to let's say in terms of yield production, to salinity, or also to stress, and that's really important to consider each crop in a separate way, and that's why WaPOR is trying to introduce more areas with the crop type maps, and that makes analysis more accurate and more reliable. I would say, because different crops are obviously responding different, and we have to address each crop in a specific way. Um, that was that's a limitation. That's why you cannot use WaPo data to every area. Only for the crop, for the field level analysis, you have to do analysis only for the areas which are covered with the crop type maps.
Right. And to add on to this, Safi, I would say like Vapor data or any other database, specific ground truthing is always required. So, you know, an additional ground information is always required. So if you supplement both of these, I think it will be Vapor data gains more advantage over over any other database. So if the field level information is added to it, is supplemented to it, I think it will be a great combination.
Yeah, yeah, that's true. That's true.
Thank you both. So, the next question is about, well, basically continues the discussion. So at what level does the WaPOR data can be best used given the resolution? So at plot, farm, scheme, or basin level?
Um, Maybe it will
Anyone?
be better that Abebe will answer this question. It's about the different spatial scales.
Okay, thank you. I will give a hit, and whatever missing, please
Yeah,
also chip in.
yeah.
Yeah, well, I would say, Kadu, it's a nice question, but it depends on purpose as well as the ground condition. So purpose, for instance, yeah, if it is a, a question, if we have question at river basin, for instance, yeah, we want to know water balance, water use, and we want to trace it a long time. They maybe then the coarser scale is still fine. Well, the finer scale can be applied, but maybe then require more uses, storage, and so on, machine power. But that is one of the activity that IG here we do the weather accounting. So such kind of weather accounting things could be done in with the coarser resolution. But with the finer, and then of course it depend also on the ground condition. For instance, we could say the 30-meter resolution might fit the smaller plot, but then how much is the smaller plot depends. For instance, in Africa, smaller plot even could be less than sometimes 30-meter. Well, often even less than 30-meter resolution, and sometimes also even if we have larger fields. Then the management could be different, and what is happening within the field crop could be mixed, and also nicely, neatly, a pixel might not fit into also a field or a plot level. So yeah, it depends. So then, well, I think this is what I could say.
Yeah,
I think I would like to add a bit on this as well. The three different levels of WaPOR are basically trying to combine a trade-off between cost, frequency of data available, and detail. So the level 1 and level 2 data is more suitable for basin scale applications, while the level 3 is more intended for use at the plot and farm level. Scheme level is a bit in between, and it depends a bit on what you want for that scheme. But I think everyone using remote sensing data should be aware of that it's not always the case that the highest spatial resolution is the best data, because sometimes it's more important to have a large area in data for a large area, or you want very frequent data. Also depends on your budget available. So really be aware what you choose when using a certain data set, and do not focus on spatial detail only. Anything you would like to add, Safi or Hammond?
I think that's really
Yeah.
comprehensive answers. Yeah.
Okay, let's go to the next one then. You mentioned the findings would help inform farmers of more sustainable agriculture. Can you explain more on how? How do these findings reach farmers, and how are they expected to reach the farmers? Hammond, I think this one is for you.
Thank you, Anne-Marie. Thank you, Sharin, for, I think this is a very good question. And even it does not only apply to the research conducted by me, but in general, like all the satellite data sets or any information that we're deducing out of WaPOR or anything. I think there needs to be more, from my personal perspective, there needs to be more work between connecting the gap or bridging the gap between the actual users of the information and the ones like the managers. For example, this information that is presently available can be converted, can be translated into an app that can be easy to use for the farmers. But yes, I would really say that the IEC gap, the information education and communication gap, between what is presently now available and how it can be translated into some informed decisions is something in the pipeline. And I think it would be very great to have enthusiastic students like you even to bridge this gap and to work on how this information can be best used to make the to to translate from information to informed decisions. I would say that. Thank you, Sharon.
I would also think that this type of information helps the sustainable development community to target farmers more adequately, to target them in the right areas, thematically, but also geographically, and not only use information that can be political, because maybe some decision maker is from a certain region or from a certain community.
Thank you, Anne Marie.
Adds facts to the decision making. So next question is from Beek. Since the prediction is based on visible data only, we have suggestions on how we can translate the prediction into recommendation for farmers on which action can be taken to improve yields. Hamid again.
Yes, Vic, relating the next follow-up question with this, I think it won't be suitable to separate vegetation indices from the irrigation or crop nutrients or any type of farm management practices, because vegetation indices are derived from the data that is in a spectral bands, and that actually represents in one or the other way all these combined factors. So it won't be suitable to differentiate between the both, but to have a relation between them. So what we are doing is trying to bridge the gap between vegetation indices and how these can be used to depict the actual condition or actual real ground conditions of the fields or farms.
Okay, well, the next comment was related to that question, but I think you already responded to that.
Yeah.
Okay, Baby. Last week we saw that the QGIS plugin is coming in that allows WaPOR crunching to get some of the indicators you mentioned. Do you know if they use the same blocks protocols for this?
Okay, hi Simon, and thank you. Well, good to bring this into my attention. I haven't really watched that. I missed it, and I really don't know. That's my answer. But yeah, if anyone knows if they use, well, definitely, of course, the basic science and the basic concept remain the same. But I'm not sure. Anyhow, I don't know. But I know that I think those maybe if they are the Aichi alumni, so they have been here, and well, I'm not sure whether they use this or they just script there. Yeah, that's what I can say.
Yeah, well, I think it's an interesting development that we all should check out in the next coming weeks.
Yeah.
I have one question to all the presenters, and that's basically how would you like to take the next steps in your work? So what do you think could be still done, and how can you further improve it? And maybe we can just go chronological. So Abebe?
Okay. Yes. Yeah. Then now specifically about performance assessment, and also I will relate it with what Simon was asking. I think the Python based may require or may not be very let's say easy for anyone to use it and apply it for performance assessment. And then relating with user interface like QGIS could be the next step. And I know Elif is also working on products related to that. So I would see then this performance assessment to go into let's say that level. But beside also let's say reducing or at least making all the limitation more visible, and then adding uncertainty of let's say the calculation we do into the value also we produce from WaPOR. So rather than taking any value calculated as a face value and then just go with it and then try to speculate, okay, it could be because of this and this, whatever we know. but rather better to put it also uncertainty within data, and also some of the variation could happen also due to non-human managed influence like climate, for instance. So this is the short term I see with performance assessment and development with performance assessment.
Thank you. Safi?
Yeah, thanks, Anna Marie. It's a good question. Actually, any framework that is developed should be tested to more areas and across more areas. I developed this framework, but at that time, unfortunately, the WaPOR crop type maps were not available for the more years, and it was really the beginning time of the crop type maps. We had the only crop type map for a few areas at that time, 2 or 3 areas. Now we have around 11 areas, and that was only for 1 year. Um, that's 2 years, and I did analysis for uh, for 2 years to identify these factors. So that are based on only 2 years data. I would like to do analysis for more years, let's say for 5 years or for 10 years. That we know that the results are really reliable and consistent. And let's say for the crop rotation, I use data for 2 years, but it's recommended that the crop rotation data should be checked for at least 5 years because the 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 disease break cycle and the nutritional improvement in the soil due to the crop rotation cannot be reflected into just 2 years data. So I would say applying framework to more years and the same similarly applying framework to other areas. So let's say apply this framework to Kenya or to Sudan, how that framework is performing in other areas. Yeah, that would be my answer to your question.
Thank you. Haven't 1 minute, please.
Yes,
We need to-
I'll be very quick, Anne Marie. So I have basically two things. One is very contextual with regards to the framework. So yes, this framework, if can be like me and Dr. Bebe are already on to this, and we may start searching on applying the framework to the actual yield. That was the question of Sander also. And so we are testing the framework for another region, but on yield. And so testing the framework, but because if this gets available to the farmers, they can use it. And the second is in the broader context, as Shireen asked, I think to bridge the gap between the available information and the users of the information can be a big, I would say, an advancement in the WaPOR. So I think it needs to be more focused and have not change the focus, but have more focus on the IEC part of the WaPOR application. Thank you so much, Anna Marie.
Thank you. Very clear. Well, thank you all for the great presentation. I think it gave a lot of insights for everyone watching. If you have any ideas and suggestions for making water productivity improvement more convenient, more easy, and to use this type of frameworks and tools, let us know. You can drop it in the chat box or send us an email. We are very interested in hearing your ideas. Please note that next week we will have another webinar, but that will be at the Cairo Water Week. The session is for free, so please register. I just put the website in the chat box, and we are looking forward to hearing more from you next week and seeing you again. Thanks a lot. And have a nice day.
Yeah.
Thank you so much,
all.
Anna Marie,
Thank you all.
for
For
the
hosting.
opportunity.
Yeah.
Yeah, thanks.
Thank you all.
Thank you.